In this video, we're going to talk about the second test. This is also one of the ones that you'll use pretty early on as you're trying to test the convergence of a series, and we've really already talked about this one. It's the geometric series test. As you can see, we know that the sum of a geometric series is a over 1 minus r, as long as the absolute value of r is less than 1. And so if you do happen to be fortunate enough to get a geometric series, then you know that the series converges as long as that absolute value of r is less than 1. And it diverges, so this is one where you do get both. You get converging if one thing is true, diverging if something else is true. And so let's take a look at example 3 to see if this series could be convergent. Okay, well, if we write out the first few terms, we can write it like this, from n equals 0 to infinity. When we write out the first few terms, we get a better idea of what's going on. When we replace n with 0, we get 1, 10 to the 0 is 1, and then we get plus 10 to the negative 1, which is 1/10, plus 10 to the negative 2, which is 1 over 100, plus ... We can see the pattern here. We can see that the first term is 1, the common ratio is 1/10, and we could say that the absolute value of the common ratio is the absolute value of 1/10, which is less than 1. Okay, therefore the series converges. And in the case of a geometric series, we can always figure out what the series actually converges to. So it converges to, we might as well figure that out as long as we're at it. First term over 1 minus the common ratio, that's 1 over 10/10 minus 1/10 is 9/10. And 1 divided by 9/10 is 10 over 9. And so this series not only converges, but we know what it converges to. Okay? And we're going to stop there and talk about, in the next video, the integral test.